The gastrointestinal tract is essentially a long tube extending from our mouth to our rectum. We rely on it to eat, break down our food, and turn it into, well, you get the picture. Due to its role in breakdown and absorption of nutrients, it's important to understand the different divisions and blood supply of the gastrointestinal tract. The abdominal section of the gastrointestinal tract develops from three embryological structures called the primordial foregut, midgut, and hindgut. And in turn, the foregut, midgut, and hindgut all derive from the three embryonic germ layers, the endoderm, mesoderm, and ectoderm. The mesoderm is what forms the peritoneum, which either completely or partially lines the organs of the peritoneal cavity, including the gastrointestinal tract. It's important to understand these different embryological divisions, as the foregut, midgut, and hindgut each have their own unique blood supply. The foregut extends from the esophagus to the duodenum at the level of the major duodenal papilla, where the pancreatic and common bile duct insert, and it consists of the esophagus, stomach, the proximal duodenum, as well as the liver, gallbladder, pancreas, and spleen. The midgut extends from the distal portion of the duodenum to the last third of the transverse colon. It consists of the distal duodenum, jejunum, ileum, cecum, appendix, ascending colon, and proximal 2/3 of the transverse colon. Finally, the hindgut extends from the distal third of the transverse colon to the anal canal, above the pectinate line. It consists of the distal portion of the transverse colon, descending colon, and sigmoid colon, and rectum. Now remember that organs with the same embryologic origin share the same arterial supply, which primarily comes from the abdominal aorta and its single anterior branches, the celiac trunk for the foregut, the superior mesenteric artery for the midgut, and the inferior mesenteric artery for the hindgut. The celiac trunk arises from the anterior wall of the abdominal aorta at the level of the 12th thoracic vertebra and the aortic hiatus of the diaphragm. It has a short course, going anteriorly and inferiorly for less than 2 centimeters before branching into 3 arteries, the left gastric, splenic, and common hepatic arteries. The left gastric artery ascends where it gives the esophageal branch, which supplies the distal portion of the esophagus. Then, it curves downwards along the lesser curvature and within the lesser omentum, giving smaller branches that supply the anterior and posterior walls of the stomach, and it also anastomoses with the right gastric artery. The splenic artery travels to the left within the splenorenal ligament, a ligamentous connection between the spleen and left kidney, along the superior border of the pancreas, and it gives branches for the body of the pancreas, a posterior gastric branch, and a branch for the hilum of the spleen. At the hilum of the spleen, the splenic artery gives short gastric arteries for the fundus of the stomach, and the left gastro-omental or gastroepiploic artery. That descends along the greater curvature of the stomach and supplies the wall adjacent to it. Finally, the common hepatic artery goes towards the porta hepatis, which is a small but deep transverse fissure through which all the neurovascular structures of the liver pass. The common hepatic artery separates into 2 main branches. The first branch is the gastroduodenal artery that descends behind the first part of the duodenum and gives 2 more major branches. First is the right gastro-omental or gastroepiploic artery, which enters the greater omentum and passes along the greater curvature of the stomach to supply its walls and to anastomose with the left gastro-omental artery. The second branch is the superior pancreatico-duodenal artery, which soon divides into anterior and posterior branches that descend in front and behind the head of the pancreas, respectively. These branches supply the head of the pancreas as well as the proximal part of the duodenum. After giving the duodenal artery, the common hepatic artery continues as a hepatic artery proper, and on its way to the liver, it gives the right gastric artery. This artery runs along the lesser curvature of the stomach, supplying its walls, and anastomosing with the left gastric artery. Finally, the hepatic artery proper branches into the left and right hepatic arteries, which supply the liver. The right hepatic artery also gives a branch called the cystic artery that goes within the hepatoduodenal ligament to supply the gallbladder and cystic duct. So, in essence, the celiac trunk, through its branches, supplies all the structures of the foregut. Let's take a quick break and try to identify the main branches of the celiac trunk, as well as the regions that they supply. Moving on down the abdominal aorta, at the level of the L1 vertebra and about 1 centimeter inferior to the celiac trunk, is the superior mesenteric artery, or SMA. The SMA branches from the abdominal aorta posterior to the neck of the pancreas, and as it travels inferiorly, it emerges anteriorly and medially to the uncinate process of the pancreas. It also crosses anterior to the left renal vein and the third part of the duodenum. The SMA runs through the layers of the mesentery and goes towards the ileocecal junction in the right lower quadrant, giving many intestinal branches along the way. The first one is usually the inferior pancreatico-duodenal artery that gives anterior and posterior branches to the duodenum and anastomoses with the anterior and posterior branches of the superior pancreatico-duodenal artery of the celiac trunk. Then, the SMA gives around 15 to 18 intestinal branches to the jejunum and ileum. These adjacent intestinal branches form anastomoses with each other that look like loops, called the arterial arcades. From these arcades arise many straight arteries, called the vasa recta, that supply and penetrate the intestines. Branches for the jejunum have fewer and larger arcades with longer vasa recta, while the ileum has more arcades with shorter loops and shorter vasa recta. Next, the SMA gives off the ileocolic artery, which supplies the cecum and parts of the terminal ileum and ascending colon. It also gives the appendicular artery that goes within the mesoappendix and supplies the appendix. The SMA also gives rise to the right colic artery that travels retroperitoneally to supply the ascending colon. Lastly, the SMA gives off the middle colic artery, which ascends retroperitoneally within the transverse mesocolon to supply the transverse colon. Last but not least, going back to the abdominal aorta now, the inferior mesenteric artery, or IMA, arises at the level of the L3 vertebra, from the anterior wall of the abdominal aorta. The IMA gives off the left colic artery that goes retroperitoneally to the left and supplies the descending colon. Next are the sigmoid arteries that travel within the sigmoid mesocolon to supply the sigmoid colon, as well as a part of the descending colon through anastomoses with the left colic artery. The last branch of the IMA is the superior rectal artery that supplies the proximal part of the rectum via the left and right branches that follow it retroperitoneally into the pelvis. Some of its branches anastomose with the sigmoid arteries as well. Let's take another break and see if you can identify the main branches of the superior and inferior mesenteric arteries. Now, looking at the blood supply of the whole large intestines, from the cecum to the rectum, we can see that all adjacent major arteries, including the ileocolic, right, middle, left colic, and sigmoid arteries, share anastomoses with each other. This gives rise to the marginal artery, which runs the entire length of the colon close to the mesenteric border, and provides adequate blood supply for the colon. Specifically, the right colic and middle colic artery anastomose to supply the right colic flexure, and the middle colic artery connects to the left colic artery to supply the left colic flexure. This anastomosis at the left colic flexure marks the connection between the SMA and IMA, allowing the marginal artery to provide continuous blood supply to the intestines from both SMA and IMA in the event of reduced blood flow in either one of these arteries. Finally, the rectum is supplied by 3 different types of arteries: the superior, middle, and inferior rectal arteries. The superior rectal artery arises from the IMA and supplies the proximal part of the rectum. The middle rectal arteries arise from the internal iliac arteries and supply the middle and distal parts of the rectum. The inferior rectal arteries arise from the internal pudendal arteries and supply the distal part of the rectum, anorectal junction, and anal canal. Finally, the superior, middle, and inferior rectal arteries can also form an anastomosis with each other. Now, let's switch gears and look at the venous drainage of the abdominal viscera. First, let's discuss how there's both a systemic venous drainage system and a portal venous drainage system. The systemic venous system occurs when venous blood drains from a single capillary bed and has a direct course to drain into either the inferior or superior vena cava, which returns blood to the right atrium. In contrast, a portal venous system occurs when blood travels through two different capillary beds, which is what venous blood from the small and large intestines do. So venous blood from the small and large intestines drains into the superior mesenteric vein and the inferior mesenteric vein through their first capillary bed in the intestines. These veins, along with the splenic vein, come together to drain into the hepatic portal vein, which is part of the portal venous system, and goes on to drain into the liver. The hepatic portal vein allows nutrient venous blood from the small and large intestines to filter through the liver to be absorbed and processed before entering the systemic venous system. Therefore, this blood first drains from the capillary bed of the intestines into the hepatic portal vein as a part of the portal venous system to the liver, then filters into a specialized secondary capillary bed known as the liver sinusoids. From here, blood drains into the central veins of the liver, which ultimately drain into the hepatic veins and subsequent IVC as part of the systemic venous system. Regarding the anatomy of the hepatic portal vein specifically, this vein arises when the superior mesenteric vein and splenic vein merge around the level of the L1 vertebra and transpyloric plane, behind the neck of the pancreas and in front of the inferior vena cava. The inferior mesenteric vein contributes to the portal system as well, most commonly draining in the splenic vein, but may sometimes drain into the superior mesenteric vein instead. Less commonly, it can drain directly into the junction of the superior mesenteric and splenic veins. Alright, as a quick recap. The primordial foregut gives rise to the esophagus, stomach, proximal duodenum to the level of the major duodenal papilla, liver, gallbladder, pancreas, and spleen. The midgut gives rise to the distal duodenum, jejunum, ileum, cecum, appendix, ascending colon, and proximal 2/3 of the transverse colon. The hindgut gives rise to the distal third of the transverse colon, descending and sigmoid colon, and rectum. The foregut is supplied by the celiac trunk, which comes off at the level of T12 and gives off the left gastric artery, the splenic artery, and the common hepatic artery. The midgut is supplied by the superior mesenteric artery that arises from the abdominal aorta at the level of L1 and crosses the left renal vein and third part of the duodenum. The SMA gives the inferior pancreatico-duodenal artery, intestinal arteries that form arterial arcades, the ileocolic artery, the appendicular artery from it, as well as the right and middle colic arteries. The inferior mesenteric artery arises from the abdominal aorta at the level of L3 and gives the left colic artery, sigmoid arteries, and the superior rectal artery. Along the colon, arteries anastomose as well, forming the marginal artery that connects to SMA and IMA. Venous blood from these organs is collected into the superior mesenteric vein, inferior mesenteric vein, and the splenic vein that together form the hepatic portal vein that drains into the liver. The inferior mesenteric vein drains into the splenic vein, or, less likely, into the superior mesenteric vein.